Compute the determinant of the following matrices by expansion of minors. So this time, let's have a 4x4 matrix and let's compute its determinant using another approach which we call as the expansion of minors, because basket method can no longer be applied for matrices larger than 3x3. Okay, so first step is to select a row or column in which you want to expand. The selection of row or column that you want to expand depends on you, okay? But I suggest you choose the one with a 0 element, because we take advantage of the product of 0, which is 0 multiplied by something is equal to 0, okay? So, if walang mga 0 elements sa isang row or column, then you may perform row operation or column operation in order to generate 0 elements. But in this problem, since we have 0 elements, in particular doon sa column number 4 and row number 4, so we can choose those column or row for us to expand. Okay, and we must also take note that each of the factors or elements in the chosen row or column has an assigned sign. Okay, so in a checkered pattern. Ang position nila is nakadepende sa ganitong arrangement. So since we're trying to expand column number 4, the arrangement will look like this one. So ibig sabihin, the first row, column number 4 will have a negative sign on it, yung kanyang cofactor, and then yung second row and column number 4, ang kanyang cofactor is plus ang sign, ang third row and fourth column, negative ang sign, and then ang fourth row, fourth column is positive ang sign. Okay, so let us now expand column number 4. So ito ang i-expand natin, 0, 2, negative 1, and 1. And then, to find the cofactors of these elements, we will introduce some blinders. Okay? Ang blinders is para siyang kanang... Okay, illustrate ko na lang kung ano yung blinders. Okay? So, first, let's expand. Okay? Let's expand 0. Okay? So, that element. So, negative times 0. So, bakit negative? Again, yung bawat position ng element ng original matrix has a assigned na sign. Okay? So, minus times 0 multiplied by its cofactor. To find its cofactor, i-crush out natin yung row and column in which naglalay yung 0. Okay? So, yun yung blinders, yung parang red lines. Then, whatever is left in the original na matrix, yun yung cofactor. Okay? Then, let's copy that one. Okay? So, that is the cofactor of 0. And then, next, let's expand 2. So, ang 2, meron siyang plus na sign. And then, ang i-crush out natin yung row and column niya. Row and column kung saan nabilong ang 2. Okay? And then, whatever is left, yun yung kanyang cofactor. Okay? Then, next, let's proceed to negative 1. So, ang sign ni negative 1 is negative. So, minus negative 1. Then, i-crush out natin yung row and column kung saan siya nabilong. Whatever is left, yun yung i-copy natin. And then, lastly, let's expand 1 or yung fourth row, fourth column. And then, ang kanyang sign is positive. And then, i-crush out natin yung row and column kung saan siya nabilong. Whatever is left, let's copy that one. Yun. So, we are left with this operation. Ibig sabihin nun, if we have a 4x4 matrix, expect that we have to compute 4 3 by 3 determinants. If you have 5 by 5 matrix, then you have to compute for 5 4 by 4 determinants, and so on and so forth. So parang ganun ang pattern. But again, you can always use row and column operation to generate 0 elements, and in that way mare-reduce ang time of finding the determinant, okay, which is illustrated in the next problem. So if pag naka-arrive na kayo sa 3 by 3 determinants, you can just use a calculator to compute the value of the determinant, okay, without showing in detail how to compute the determinant of a 3 by 3 matrix. Okay, so we have -0 times -36 plus 2 times 24 plus 1 times 12 plus 1 times -36, and then simplifying further, the answer is 24. So this time I have a challenge for you. What if you expand rows 1, 2, or 3? Okay, so you choose either row 1, row 2, or row 3, and then do the same process. Will you get the same answer? Okay, or pwede then expand either columns 1, 2, or 3. Will you get the same answer? So if you have a solution to share with me, then you just send to me your solution paper through Google Chat, and I will try to check it out. Okay, thank you so much.